nice weather up there.
Yeah.
Nobody here yet, huh? It's still
No,
early.
you're the first.
Yeah. So, it took a table, oh. I don't want to take someone's seat, but I'll sit in front here, guys. I don't think no one's seat, but
Maybe Jeremy will not come.
yeah.
I have a grade class 3.
You ready?
No, not
Yeah.
So Thursday.
Okay.
Yeah.
Yeah, one of the problems I did not do, and I try to solve it at home. I couldn't, the one that says, when it's between, what is the value between this number and that number, and yeah, I'll get the first two, one, A and B, solve it for one value, I will solve that, but when it comes to two value, I forgot how to do it. I was looking, I couldn't figure it out. And that was the last, I didn't do that. I don't even did it right, but. And this material is so much for this week.
Mm-hmm. Busy. It's good because this is our last week, so.
This week?
Yeah.
But next week is our last week.
Oh, for the makeup class.
I want to do a presentation.
Yeah, that will be.
I wanted to come in yesterday, but I didn't talk to you yesterday, so I didn't want
I
to come
know,
up.
yeah.
So I was like, well, I talked to you, so I didn't want to show up like that. But,
Yeah, Ernie and I were about 5:30.
oh, you were there yesterday?
Yes.
Oh, I was just, man, I was hesitating, I'm like, should I go there? Or maybe, yeah, I was like, I sat up a while, like,
Yeah,
I want to come, but I'm
maybe
like,
you get my email so you can email me.
yeah, please. That's when now, like, ask for your contact, so I can be able to, if,
Yeah.
how you doing, sir?
Hi, sir. How are you tonight?
I'm okay, hanging in there,
All right.
can't complain.
Hi.
Oh, thank you. Yeah, I was just hesitating yesterday, I was like, should I go there, because I didn't talk to you, so I didn't want to show up like that, and knowing, that's why here steady. Yeah. Something always good to go with your instincts. Like, there's something always good to go with your instincts, what your mind, your first thought. Suddenly yesterday, I think I should go over there, people will be there steady, and I'm like, you know what, they didn't talk to nobody, so I don't think we'll be there.
You did it right. Same for me. If I'm on top of a tall building and I go out to the edge, my instincts tell me not to jump. I don't jump.
I always got on that top.
We're the same.
That's a different instance.
I got another question.
Okay. Also, my instincts told me you weren't going to come yesterday.
No, I really wanted to come because what the schedule I've been on, they've been allowing me to leave work, stuff like that. I left work early yesterday. I was home by myself, my wife and kids go to school. She usually pick them all from school, from work. So usually come home like around 7. So I was just sitting home by myself.
Well, we weren't here, as you now know, because we made that decision too. And since you already told me you were gonna see me Tuesday,
Yeah,
I
that's
figured that's what
I
you
thought that
meant.
too, so,
Yeah, so that's the way we came down. Okay, question, ma'am?
Here she also love this helping with that second, so it goes with
This is the type 1 and type 2 also? Reject null when it is true. Fail to reject null, that is mu 4, but it is not true. Reject null that p equals 0.60 when it is true. Fail to reject. Yeah, she can't say accept. You got to say fail to reject. So hit a 0.5 on those, 2.5 out of 3, right?
but this one is still.
3 or 3, yeah. Okay, now when you get the grades, you can just put those test grades in this new sheet, okay?
Sure.
Yeah. You have the old sheet? Where'd you get this from? When? You gave it to me when you went.
I know, so you put it there and the.
I put it there in the thing.
And the,
I spent 2 days looking for it. I put it there in the what, in your stuff?
in my, Xerox, materials.
I looked everywhere for it.
I'm sorry.
Except there. No, it's my fault. I'll just.
I
Failed to remember. I failed to remember. It's not that it was lost, it was that I failed to remember. I did make a mistake, I failed to be correct.
That's the day going.
So it's a bear, man, it's uphill all the way, walking through a swamp. That's what it is.
And the weather, a couple of people talk about the winter in Massawa here. When I first got here, I guess I'm lucky. Everything's been kind of quiet.
This is not winter. I don't know what this is, it's not winter.
I know, I like it though. I lived in Minnesota for 6 years.
You know what winter is.
Yeah.
You know what winter
I lived in
is.
Minnesota 6 years, man. There was no, I don't care how bad the weather is or you still have to go to school, you have to go to work, there's no time, day off. Like other states, when they have things going on, like, okay, everything's shut down. I was in Minnesota.
No, Minnesota, it's a normal day, you just put your boots on and go.
Just go.
That's right, and that's absolutely true, weather doesn't stop anything in Minnesota. People are tough, they don't think twice about it. But you will not find a winter in Massawa anything like you've seen in Minnesota.
Oh, yeah?
Even at the worst, they're not anywhere near what you know.
Oh, okay, because I wouldn't say worse, I was trying to compare with what I've been through in Minnesota.
It very seldom gets below 20 degrees here, almost never below 10. And we almost never get more than 2 feet of snow on the ground at one time. So this is gonna be like nothing to you. I know what you get in Minnesota,
Oh, man, I remember it was.
minus 10.
Yeah, it was 2007, was below 10 for a week, straight, 7 days plus.
Well, that was plus 10. This year it's minus 10 in Minnesota?
I mean, it was -10.
-10, yeah,
Yeah, for
okay.
a week straight.
That's it, that's what you have,
Below,
yeah.
yeah, below 10 degrees. And we had that for a week, and we would still go out, you still see people going to party, they would dress up and still go out to go eat in us cold weather.
It's just fun,
It's just normal life for
it's
everybody.
just fun. If it gets down to -40 or 50, they might consider it.
Yeah.
Minnesotans are outdoor people,
So yeah, 10,000 lakes, man.
outdoor people.
I'm afraid you always just thinking to go deer hunting in the deer season. I'm afraid of going to hunt because every time I watch TV, someone gets shot mistakenly by it. So
Well, that's good, that's how they make TV. I mean, you gotta look at the percentages.
that's true.
Yeah,
Yeah, I have to go there once in a while and take them go hunt.
cold, it gets cold out there.
So
And if you do shoot one, you gotta drag it out.
Gotta drag it out.
Yeah,
sometimes if it's far away from where they actually killed the deer, they would just cut it open, take the guts out, and try to pack it some way and take part
it's a long pack out.
Yeah.
So gee, I wish I hadn't shot this thing. That bullet was a lot lighter than this deer.
Yeah.
Yeah, packing out 100, 200 pounds.
Well,
Hmm.
if you mind asking, what state are you from? What part of
New
the-
York, Long
New
Island.
York.
But the Air Force sent me to Alaska, so I experienced a little outdoors there. But I'm not much of a hunter or fisherman. My heart's too soft. I got a soft spot for anything that's alive. Yeah.
Yeah. Where I grew up, we hunt for our food, so everything we have to look for it to get it, to eat. Especially when I grew up, I was like 11 years old when the war broke up in Liberia, the Civil War.
Mm.
And 14 years, it wasn't easy because I had to leave to cross and go to Cote d'Ivoire, the Ivory Coast, and where most of the refugees were, and people leave from the Ghana and other places to seek refuge. And during those days, if you get a cup of rice, it's like gold.
Yeah.
Yeah.
So you know what a thin meal is.
Oh,
No, for
more
sure.
than that, and you
And
lot of
water,
years.
shortage of water too, right?
source of water. If you're lucky, you don't go, you go up without food for a day, that's good, 2 days, but sometimes you go off food for 3 days and the third day, if you find something you're happy. So all day, all food, it's a normal day, you stay stronger to go ahead and do what,
Aye.
That's why when I came to the States, when I came as a refugee, through the immigration, UN and Lutheran World Service,
Yeah.
they had a program for resettlement for refugees. And I was lucky by some chance, as a family in Georgia that
Yeah.
sponsored me. And from nowhere, they didn't know me, who I was. They sponsored me, I came to the States. They took me to Georgia, Athens. Took me to Athens, and I was there for a month, almost 2 months. They put me on my feet. They actually got my paperwork, got me my first job, and just wanted to have a better life. I still correspond with them because my family still talk. They're a very good family.
Well, they got a good man also. You did your part. So it was good for both sides. Well, you've got quite a story.
Oh man, sometimes I tell people what I've been through. It's a privilege when I see myself today, being where I stay, and my other people, my friends that we all grew up together. It's just beyond words. I really can't comprehend. So I can be shocked every time when I sit and reflect on my life, to see where I am. especially when I first joined the Navy, it was hot. I mean, it was shocking.
Am I too early?
No, no such thing. As long as you can tell lies like we are.
Hey.
Only his aren't lies.
Yeah.
I mean, they're more unbelievable than lies, but they're not lies.
I mean, some of the things that I feel is like going through. I mean, the thing is, you know, what people say, what doesn't kill you makes you strong. I mean, some of the
No,
things.
up to a point.
So,
Up to a point, then after that, you start to die. Oh no, up to a point.
so yeah, some of the stuff I went through, it made me who I am today.
Yeah.
I appreciate life as well.
Story.
Well, I see people taking advantage of the opportunity they have, and they just.
Yeah.
break it.
They don't know. They don't know. They have no idea.
I work, some of the kids I work with, are like, you know, military is very easy to follow, just rules.
Mm.
Do this, you'll be fine. Don't do this, you get in trouble. All you do, don't do what's safe to do, just, you don't, you know, it's easy. But they'll go ahead and do some of the.
Well, it's not easy for somebody that's spoiled. And I think you know what spoiled means, right?
Oh, yeah.
They have trouble with that. They do. See, they're not as fortunate as you because they didn't grow up in extremely tough circumstances, so they ended up with a good character. So you see, you have to give them a break because they weren't as lucky as you to grow up in such a rough situation, so to turn out to be a good person. What can I say?
It's
What can I
opposite.
say? What can I say? Yeah, you just gotta cut him some slack.
Does anybody else need a drink?
Oh, we're good, thanks for thinking about that.
You guys?
Nice. I feel it, Joe.
Hello, hello. About ends.
You sure did.
It's my thing. I like it. Pen and paper, so. You ever wondered why my homework's different colors? It's not for your sake, it's mainly because I just can't.
You didn't have to say that.
No.
You didn't have to say that.
I mean, I circle them for your sake, but I decorate them because I just think they're awesome. So you should appreciate the colors,
Well,
that's about it.
I do, and I'm gonna get to keep them.
Yeah, I'm gonna bring them all to you on,
Thursday, Friday.
Christmas, yeah. I had it on the website, I didn't wanna bring my whole binder for.
Well, this week is a rough week in statistics.
It is
A lot of crunchy stuff.
correlation and recursion.
Yeah.
I went through these videos over and over.
Yeah, but it doesn't get any better, does it?
Trying to read some of the stuff to make sense of it. I
No.
can't.
You need teacher in this one.
I realized like some of the stuff we did the last week of 103, it's kind of, well, it was almost, I don't know, just the regression part. I don't know, it's a simple thing like that, because I was trying to figure out, when my old notes, I was looking back and, you know, like you get X and Y, and then you try to get X squared, then X and Y, multiply that, and you get, but then when I look at the formula for regression, that's what just threw me off. It's like, you know, X squared multiplied by X, Y multiplied by.
Well, you're gonna get a chance to remedy all that situation, because we're gonna do just such a calculation in about a half hour. And everyone's gonna share your misery. But I've got the
I'm right
math,
there with you.
I've got the Math 103 book open right here, because I'm gonna use it today, because Blitzer does do a really good job on this.
I make some calculators that you can plug it in.
No, I've never heard of such a calculator that would do that. I almost got it put out of a job there. So Laura has got a very interesting statistician that she's going to give her talk on. This guy, when he was a student, took a statistics course. In fact, it might have been his major. But he had trouble getting to class on time. He was usually late. And one day, he was late to class again. And before that, before he made it to class, the instructor was talking about some of the major unsolved problems in statistics, things that nobody could do. And on the board, he wrote down 2 of the outstanding unsolved problems in statistics. And then he went on with his lecture material. And then finally, our hero arrived to class, sat down, and he wrote down what was on the board on his notes, didn't know what it was. And that night he did it because he thought it was the assignment.
Oh, goodness.
And I guess he came back the next day and he says, you know, that assignment last night was a little
A
hard.
little rough.
And the professor said, there wasn't any assignment last night.
What would it do to him?
Well, it was famous after that. I mean, the school fired the professor and gave him the job. So I can't wait till Friday when Laura tells us all about this student. If that's what he did for openers. I thought it was the homework, so I did it. Oh, sure.
I'm so happy, I'm so happy.
You got new toys.
Yeah. They're so colorful. They come in this empty cup.
No, they go right in there and then it closes
gotta
up
press
fat,
the
and there it
button.
is.
They come
Wow,
out.
they come out, it opens up, and they're all right there.
Yeah.
You use any one that you want.
Yeah. They're all brand new.
Wow.
And they come in neon colors, so I have to put it everywhere.
Joy.
And they got here in like a week.
Oh, you had to order these? You
Yeah,
could-
I bought them on Amazon.
And they were just as good as you hoped they'd be, right?
Yeah. Well, I haven't broken them yet.
Karen?
Sneak behind you today.
Oh, well, I moved up a row,
Oh,
so.
I took the back table away, so
all
we
right.
changed the game.
Change it up on this.
I'm gonna be my sidekick today on here.
Oh, well, I can do that.
It's all good.
Yeah, we can do that.
How about a stomach kick?
Yeah, there you go. So, I have a slight problem with Friday.
With Friday?
Yes. So you see, next week is spring break, right?
I wish, it's spring break for you.
Yeah, well, for Ron too. So, it's our 40th wedding anniversary, and on Saturday
To make a
morning-
long story short, your
Yes.
excuse.
Well, I can be here for a short time. But-
Don't come if you get busy at the last minute or something. You've given your talk, and your classmates will miss you if you're not here to hear their talks,
Yes.
but that's just tough
Yeah.
if they do. Your
Well-
excuse.
Okay, because I have to fly early on Saturday to Sydney, Australia.
Oh.
Not to rub it in,
Yeah.
but yeah. 40th wedding anniversary, can you imagine?
Congrats.
same man.
What was I thinking?
Not to rub it in here, but I'm not even that old.
Well,
I know. I have children older than you.
I don't approve of these trial marriages.
Yeah. took me 10 years and 3 children before I finally got the official wedding ring.
He's thinking it over.
No, I think I was.
He's Norwegian.
You
That's
haven't
true.
been together that long, if you still wanna get out of it, it's okay.
Yeah.
You can still apply for an annulment, it's all.
There you go. Well, no,
Annulment.
40 years.
it's funny, he found this article about this couple that has been married 82 years.
Mhm.
And so I thought, well, geez, they must have been married when they were 13 or 14, but no, the guy was 26. Well, Ron was 30 when we got married, he's 11 years older than I am. So it's like, man, we could be married 8 years, oh no.
82, you guys aren't even halfway there.
I know, it's like, dang,
That's just outrageous.
but anyway.
How's your Norwegian?
I can say mini puss and tuck.
No, I saw him just a few minutes ago, he's fine.
Oh, that Norwegian. Yeah, he's still Norwegian. But I know how to say ofte and many tusen takk. I can be polite in Norway, and that's it.
Your accent's pretty good.
Yeah, well, in order to get accepted into the Jorgensen family, you have to say ofte properly.
Say it one more time.
Ofte,
Ufta?
yeah.
How's that? Ufta?
Yeah.
Ufta.
It's what you say when, instead of cussing, like, oh, or stuff like that, yeah. It's
You
ofte.
need to know that to get in the Jorgensen family? Are you sure you want to get into the Jorgensen family?
Yes, well,
Ufta.
yeah, ofte.
I'm gonna use it.
There you go.
No one's gonna know.
I know, they're gonna,
Usta. Ron's gonna say, how are you today, Tom? Usta.
no, ofte.
Ufta.
UFF, DA. Sorry,
Uf-
I've
Ufta.
never actually.
Oh, it's like a dog sound. Oof.
Yes,
Ufta.
yes, so,
Oh, I found out how to understand Egyptian hieroglyphics.
That's useful.
you ask an Egyptian?
It's astounding. I'm gonna write it on the board. Okay, now what I've written there is a picture of a bee
Yeah.
and a picture of a leaf. So the word I've written is leaf.
Oh, wow.
It's pictorial, and the pictures stand for sounds. The pictures don't stand for the object, the picture stands for the sound that the object is pronounced into.
Ha. Cool. Okay, so if we remember that for the quiz, do we get extra credit?
Extra credit.
Yeah, because we're the,
Tree, that's be a tree.
Yes.
Okay,
extra credit.
Credit,
Credit card.
credit, craggy, credit, what's the sound, it's high. Well, I can have a pit, like a pit in the truth, and minus, P, which is, never mind what P is a P. Okay, so that's close, that's what you're trying to get me to do, something, yeah. This is not my first day. I've handled, obtuse students prior.
Well, I could always tell you the expression that my husband uses for situations
Woof,
like
duh.
this. No, he has a different one. So, but I wanna at least get a decent grade in the class, so I'll tell you after the grade is final.
Yeah, right, that's just what I was gonna suggest. Hold back.
Oh, goodness.
Yeah, that's a problem, Ron has too many expressions.
Oh, you gotta start on homework, huh? I haven't made it that far.
Well, they do look nice, I will say that.
I have,
I know, I sent
So
pictures
this
of
week
these,
is supposed to be easier than last.
that's what I was waiting for.
They are nice colors too. In fact, I like the color of the stems,
I'm going,
that sort of yellow
through the
tint.
readings
And
and
it's funny,
watching
because I
everything.
found them on, I saw a picture of students in aesthetical preferences, like how they were studying, and I saw
So,
them in like 50, and I was like, I must have these magical.
So you
weird
emailed the
plans.
student?
No, I took a picture of it,
From last.
looked at it, and then Googled the picture to see if I could find them, and then I found them on Amazon and bought them right away.
That's
That's
amazing.
what I-
Was the label visible in the photo? No, they just, Google isn't incredible.
Cause you can take a picture
And then
of a thing, and then you can search the image itself, and it will come up with the
Whatever,
website.
I mean.
And just like that too.
Yeah.
It's amazing.
And there's also a, Google character thing, where you can take a picture of Japanese, and
Well,
you
the
can
last
search the
one's
Japanese, and they'll tell you the translation.
Yeah,
Because I
that'll
didn't
be
get the
image
last one.
recognition, that I'll go with.
I was like, wow.
Yeah.
Well, you know what they really do in the YouTube is they audio everything you put out on YouTube, and if they find that it's a copyrighted song, then they'll silence you.
Yeah.
And you imagine the megabytes that it takes to actually compare everything to every registered copyrighted song, and to find note identicality? Because I don't think they're paying somebody to listen, it's gotta be done by machine.
So it's like, I think I misread something.
Yeah, they cut me out.
Well, they're doing pretty, really?
Well, yeah, because I videoed UMUC's graduation,
It's more than 20.
and the band was playing a song, I didn't know what they were
Oh,
playing,
yeah, I think I.
but it was a copyrighted song, so Google cut me out. So I explained to him, and they put me back in. We got 5 minutes. Hello, Ernie. Hideo, how are you? Good to see you.
I like your hat.
Yeah, she loves purples and lavender.
Hi, how are you?
And blues and greens. Chartreuse. Actually, most students today don't know what the word chartreuse is, but I know you do.
What happened to my print job here?
Can you find your chartreuse?
There, the color number 6.
State.
It's sort of a brilliant yellow green. Yeah, be that one, yeah, that's the closest you got. Chartreuse. Yeah.
They have the column number.
And you know what okra is? Okra. It's a burnt yellow. Yeah, burnt yellow. It's almost the color of your stems, but too much pink.
It's like a brown. Yeah.
Close to brown, yes.
I started.
When did they arrive? Today?
Yeah. I was walking over here and it was like, your friend came in, so he pulled over and.
Hi. How goes Sean? How much they cost you?
But 6 of them were shipping, so.
Well, if you get $25, you get free shipping, so you lost $1. Could've got something else.
I don't know, 'cause I was gonna buy more, but I didn't wanna shell out more. But in my head, $20, 20 pins, $1 for pen.
They'll last you for years.
Yeah,
You don't
that's
need
what
any more.
that's what I heard, they said that there's this person who said their brand just ran out, and that was like within like 10 years, they were so slim, and I was just like,
Quality cutting. Would find.
sorry. Are you okay?
Yeah, this is what it looks like when he's okay. You don't wanna see him on a bad day. He's got this statistics blues. It's not the amount of classes, it's the amount of material. Oh, 2 minutes.
Now, the problem with that is now, the expectation is too high. And
You
so-
set the bar too high.
And so everything after that, you know, I'm gonna be screwed.
Yeah, 70s from here on out, no.
Well, and then, the online course isn't taking spring break, so next
Oh,
week I
goodness.
have class. I mean, I have to start, I mean, you've gotta be fully committed. This is so University of Long Island, taking the same spring break. This
So
person
30
has to
seconds?
do all this. One of them left.
I'm sorry, I jammed it.
Yeah,
Can you
there's
fix?
Troy and who's the other one? There's actually three.
10 seconds. 5, 4, 3, 2, 1. Howdy, everybody. Welcome. Going to start this class off. First, a little bit of administrative announcements. Just in case you didn't know, we will have a test in 48 hours on Thursday. It'll be our last test. Don't cry. And before the test, we'll have some problems on the whiteboards, many of which will be on your test, so you really want to have them up there. And if there's time after the test, which lately there has not been, then we'll get a talk in. And if we don't get any talks in, then we still have 8 talks to give. That means 2 hours. And that will be done on Friday, when we have a 2.5 hour scheduled class for no other purpose than to give talks. So you see, we're capable of giving 10 talks in 2.5 hours. So we're getting off easy if we just give 8. So attendance is required unless you have your 40th anniversary at that time, in which case exception is being made. Otherwise, attendance is required because there's certainly going to be 10 people present because they have to give talks. And the other 2 people should be here just out of courtesy, even though they've already given their talks. Courtesy is always nice to have. Now, those of you that have been keeping up with Leo are getting those points, 2 points a week, and that makes a difference because they're easy to get. All you have to do is watch, basically. So you want to definitely get those points. You also want to get the max points on your 15-minute presentation by giving us some good statistics. Almost everyone has chosen a statistician, so we want you to spend no more than half your 15 minutes on the aspects of his life, some of which are definitely remarkable. But then we want you to spend the remainder of the 15 minutes on his statistics, so that the class gets some statistical education. And now you definitely want to rehearse your talk. If you come in here with an unrehearsed talk, you usually blunder through it, the time management doesn't work right, and you don't communicate with your audience. Not only do you want to rehearse your talk, but you want to internalize it. You want to put it in your heart. Because if you stand up here and read what you printed out from Wikipedia an hour before the class started, then you're not getting anything across to your audience, because they don't listen much to people that just read. They listen to people that speak, and especially if you speak from the heart. So it doesn't do that much better if you just memorize what you printed out from Wikipedia and then recited it by rote. What you have to do is make it personal to yourself. Live it. So then when you talk it, the people are automatically glued to you, magnetic. And then the talk is very successful. So are there any comments, remarks, suggestions before we kick off today's material? Correlation. So I'm going to start with the basics. This is a presentation that I give in Math 103. It'll last about 5 minutes, and then we'll leave Math 103 behind us, and we'll venture into the higher levels of Stat 200. But please tell me what I'm doing when I do this. Besides a hula dance, which is close, notice here I have 2 parameters. I have my right hand and my left hand, 2 parameters. In this class we call them X and Y, X and Y. When one goes up, what does the other do? Also goes up. When one goes down, what does the other do? Also goes down. So these 2 parameters know about each other, do they not? They're correlated. When one does something, the other does a predictable other something also. And since they're both doing the same thing at the same time, they're held to be what is positively correlated. They're correlated in a positive sense that they're both doing the same thing at the same time. So I'll give you a real-life example of the speed with which you drive and your stopping distance. Suppose you drive at a speed of 30 and your stopping distance is, say, 60. And suppose you drive at a speed of 40 and your stopping distance becomes 80, and you drive at a speed of 50 and your stopping distance becomes 100. So here we have a data table, 2 parameters, and we have a list of data points. Each point has 2 values. Now we're going to call these x and y, and the x is usually identified with the independent variable, the one that you have control of. So which is the one that you can control, your speed or your stopping distance? Speed. So the speed becomes the x, and the dependent variable becomes the y. The next thing that we do is try to graph the data table onto an xy space. So you put the 30, 40, and 50 on the x, and you put the 60, 80, and 100 on the y. And then you plot your 3 data points, 1, 2, 3. This is now known as a scatter plot. And the next thing that you do is determine the mean of each one of the variables. The mean, x bar, is equal to 40. Do we agree to that? Y bar is equal to what? 80, okay? Now, this is sometimes called mx by Lane. This is called my. So it's just notation. Now, this is now our x bar, y bar point, agreed? So you can find your x bar, y bar point in the scatter plot at some point. It's not always a data point. In this case, it is. The next thing that you do is pass the best straight line that you can through your data points. This best straight line that you can pass through your data points is called the regression line. And it's a straight line. So because it's a straight line, it has a generic equation, y equals bx plus a, where b is the slope of the line, and a is the y-intercept. This is review from Math 103. In Math 103, you called it y equals mx plus b. So it's the same equation, but you're just using different variable labels. So b is the slope and a is the y-intercept of this straight line. And you know that it's a straight line because both y and x are present to the first power. When y and x are both present to the first power, that identifies that the plot of this equation is going to come out to be linear or a straight line. Linear because it's a straight line. So y and x are held to be in a linear relationship if it is a straight line, and it is. So this is what's called perfect correlation. The reason it's perfect is because all of the points lie on the same line with no scatter about that line. And the increase in y is always in the same proportion to the increase in x. Here, if you increase x this much, you increase y that much. But here, if you increase x by the same amount, you will increase y by the same amount. So the change in y is directly proportional to the change in x. So this is perfect linear correlation. And we have a measure of correlation. It's called the Pearson correlation coefficient. Now, if it's a sample, then we express the coefficient by the letter r. But if it's a population, then we express the correlation by the Greek letter rho, which is pronounced R-H-O. And it's written sort of like a sloppy P. So if you don't like to pronounce it rho, you can pronounce it sloppy P. Rho is definitely more professional. So if you're talking about the amount of correlation that's present in a population, you use the Greek letter rho. If you're talking about the amount of correlation that's present in a sample, you use the Roman letter R. Now, if it's a perfect positive correlation, then the amount of correlation is a perfect 1. Meaning that everything is on a straight line and is perfectly proportional. And you cannot have an amount of correlation that is higher than 1. It already is a perfect correlation, meaning that all of the points are on the straight line. Now, one thing to point out is that the value of R represents the amount of correlation. It does not represent the steepness of this line, because I can change the steepness of that line just by changing from miles per hour to kilometers per hour. Then all of the points change their slope. So the slope of the line is mostly dependent on the units that you choose. But even if you change the units, the amount of correlation on the data will not change. The value of R is units independent. But this is perfect correlation, and we don't live in a perfect world. So let's look at what you usually get in our imperfect world for your scatter plot. What you usually get is a scatter plot that looks like this. Now, this does represent positive correlation, because as x goes up, y also goes up in general, agreed? And therefore we can draw the best fit line through it, and I'm going to draw the best fit line through it just like that. Now, the reason that this is the best fit line, and this line will have some slope, and it will have some y-intercept. Here's the y-intercept down there. And that is what identifies this line, and these data points are generated from an XY table. The XY table is the only data that you have. Since it's the only data that you have, then the XY table is also sufficient to generate the slope and the y-intercept. So if you have an XY table, then how can you find the slope of the best line? The slope of the best line is the sum of the x deviations times the sum of the y deviations over the sum of the x deviations squared. This is an equation that is in Ilkowski. You can find it. There are other equations that will give you b. There's another one in Blitzer that tells you that b is a slightly more difficult form to write. So I'll write it and then erase it. The Blitzer form of b is n times the summation of xy. N is the number of data points. Minus sum of x, sum of y. And it's divided by n sum of x squared minus sum of y. Now, these two equations are equivalent algebraically. If you have one equation, you can make algebraic substitutions and turn it into the other one. So feel free to do that if you care to. So if you want to calculate the regression line for any set of data, you need to know its slope and you need to know its y-intercept. You generate the slope by using one of these equations on your data table. And we'll do that by example in a few moments. Then once you know the slope, there is a fast way that you can find the y-intercept. Because what you have right now is the equation. Suppose that the slope turns out just to be, say for example, 2.7. Then you now have the equation that the y value of the regression line is equal to 2.7 times the x value plus a that you're looking for. And this is true for every x and y that's on the regression line. Now, it's also an algebraic fact that the point that we looked at a moment ago, what was this point identified by? This was what point?
Read it back.
X bar, y bar, agreed?
Or in-
The point x bar, y bar is always on the regression line. So therefore, you can put x bar, y bar into this equation. Y bar minus 2.7 x bar plus a, and this permits you to find out what a is. So you can use the known point, x bar, y bar, into the equation and give you the only remaining unknown a. So this is how you find the regression line from your data table. Now that you have the regression line, yes ma'am?
Will X bar and Y bar always be paired coupled?
No, I'm making them. I'm saying I'm creating a point that has an x value of x bar and a y value of y bar. I'm creating that point. It doesn't occur as in the data table at all. It's a manufactured point. From the data table, you calculate x bar, and from the data table, you calculate y bar. That is not necessarily a point in the table. It's a created point. But that created point, algebraically, will always fall onto the regression line. So it gives you a point that's on the regression line. Now that we have know how to calculate the regression line for a distribution of points, the next thing that we want to know is how to calculate the correlation coefficient, which tells you the amount of correlation that is present. Now, in this case, it's not perfect, is it not? Because not all the points lie on the regression line. The points are scattered about the regression line, agreed? So it will not have a value of r equals 1. For this one might have a value of, say, r equals 0.8, meaning that it is positively correlated, but it's not perfect. Or if it was a population and not a sample, it would have a rho of equal to 0.8. And we now have to ask, how are you going to calculate the exact value of the strength of that correlation, the value r? Well, we also have equations to calculate r. So the equation for calculating r Nux, what did you do with that page? It's gone. It's not gone, but it just comes back again when you least expect it.
Extend it?
No, that
No?
just makes this one longer.
Oh.
So, well, I guess I can always do it again if I get that desperate. Okay, now, so the way that we calculate r is by using the equation. It's the sum of x minus x bar. Now, you notice that x minus x bar is a quantity that you are used to calling by a certain name. What are you calling x minus x bar? What's the name of that? Hint, deviation. It's a deviation in x, is it not? Times the deviation in y, and it's over the deviation in x squared and summed. This gives you the value of r. Now, there are other equations that can be used to calculate the value of r, which, if I write them down, will make you appreciate this one. This one is in Ilkowski, but this one is also in Ilkowski, as well as being inside of Blitzer. Now this, the particular equation is in the formula sheet. Actually, it's in the key terms of Minkowski, so you can locate it easily. And even though I'm asking you to memorize the key terms, I'm not asking you to memorize this formula. Of course, a serious student will, but it's not required that you memorize this formula.
Wow.
That's a square in the top one, right?
Gotcha. So, Kayla already sees the pattern, so it's not gonna be hard for her. So this is one square root, and then there is another square root, which is the same thing with y. So you can use this formula or this formula to calculate the value of r. So these are the two parameters that you have to calculate to identify one correlation from another correlation. That is, you have to calculate the regression line, which means that you need to get the slope of the regression line and the y-intercept, and we've given you equations for doing that, and you need to calculate the strength of the equation, the strength of the correlation, which is either going to be R or rho, depending on whether it's a population or a sample. And we are giving you now equations for making that calculation as well. So if we go back to our beginning one, if it's at all possible, then we identified that this was a perfect positive correlation. So it had a rho or an R of 1, and then we went to an imperfect one, and we identified that we would have a regression line that would not pass through all of the points anymore. So now, what am I describing to you now? Are these two parameters correlated? If one is doing something, from that something, can you tell what the other one is doing? Yes, but this is what you call some types of relationships that your friends have, right? It's totally dysfunctional. When one goes up, what does the other do? Down. When one goes down, what does the other do? Predictably, every time, agreed? Blitzer has some very strong remarks in his text. You might say he's actually bitter at some points. But he says, for example, my wife and I were happy for 20 years. Then we met. Let it sink in.
Mail order Brian.
Okay, so this is what we call a perfectly negative relationship, agreed. Can I give you a real life example of a perfectly negative relationship? How about the speed with which you drive and your miles per gallon? Your gas mileage. If your speed goes up, what happens to your gas mileage? Down. If your speed goes down, what happens to your gas mileage? Up. So this is strong negative correlation, agreed? So suppose that you're used to driving at 60 miles an hour and you get 20 miles per gallon. So you come down to 40 miles an hour, suppose you get 30 miles a gallon. And you come down to 40 miles an hour. Yeah, right. So,
You're already at 30 and 60 miles an
Should be 20.
Actually, my mom's car, we filled up once, here, traffic,
hour. Say we're talking.
till Maury and back,
Okay.
and then Tijuana and back.
let's do it the other way around, I think it's easier to figure.
And it's 7.
Suppose that you go 40 kilometers and you get 20 miles per hour. So you take it up to 60 and you get 10 miles per hour, you take it up to 80 and you get 5 miles per hour per gallon, okay? So now let's see what these data points look like. First, which is the x and which is the y? Speed is the x and miles per gallon is the y. So this is the y and the x, and these are our 40 and 60 and 80. And now this is going to be 20 and 10 and 5. Now when you go 40, you get 20. When you go 60, you get 10. And when you go 80, you get 5. So this is our scatter plot. Now, if we pass our best fit line through it, then that line will go through all of the data points. So this is called a perfect negative correlation, because all the points go on the line. And when x changes by a certain amount, then y goes down by the same amount every time. So the proportion is the same between all data points. So this is perfect negative correlation, and it has an R is equal to -1. Or if it's a population, rho is equal to -1 for a perfect negative correlation. So what you see is that R and rho vary between 1 and -1. And let's plot an imperfect negative correlation. So let's take some data points. No. Okay, so now do you get the feeling that this is indeed negative correlation because the general trend of the graph is down and to the right, agreed? So as x increases, y comes down. So this is indeed negative correlation, but it's not perfect because you cannot pass a single straight line through that. So you pass your best fit regression line. This is y is equal to bx plus a. And we have some formulas that we've given you a moment ago that enable you to find x, b and a generated from the xy table. But there's one very special point, and that point I'm going to illustrate right here. And this point is called the what point? X bar, y bar, and it is on the regression line. So I can, in general, extend this line right here, comes over here, and it's going to be at y bar, agreed? That's the value y bar. Now I'm going to take, first I'm going to go back to a positive line, because I think things are a little bit clearer. Too bad I have to draw another one, but that's not a big deal. So I'm going to have these 4 points, and I'm going to draw my regression line. Now, and indeed, there is a point x bar, y bar, which is right in the middle. And if you bring this over to the graph, then it comes out at y bar. Now, we're going to identify some aspects about these scattered data points. First, each data point is a certain vertical distance away from the regression line, true? And I'm going to draw these vertical distances. Now, that line is the regression line for which the sum of these distances is a minimum. The sum of these red lines is a minimum if that's the regression line. If I can draw some other line at some other slant in some other space which has a lower summation of red lines, then that other line is the regression line. So the best fit line is the one that's closest to the mostest. Now that's not quite sure, because we don't minimize the length of these red lines, but what we do is square each red line. And then we sum the squares. And that blue line is the regression line for which the sum of these squares is the least. It's called a least squares fit. So we don't minimize the actual vertical distances, but we minimize the vertical distances squared. Now the reason that you square them is because it takes care of the plus and minus signs, agreed? You don't want to average a -3 with a +3, it produces 0, indicating no scatter, but there definitely is scatter, agreed? So you square them to get rid of the minus sign. So let's take our set of data again. And I'm going to draw my regression line. And I'm going to draw these vertical distances. Now these vertical distances are called residuals. each one of these red lines is a residual. Now, I'm going to take this point right here to be my mean, x bar, y bar. Is this point right here. So that means that this distance right here is y mean. Now, I'm going to put a couple more points here in very suitable places. Suppose I have a point right here, and then a point down here, say another point up here. Now, this point right here has a value of x and y. It's arbitrary, agree? This has an x point and a y point, this arbitrary point. Now what I'm going to do is to draw its x value, its y value. Do you agree that this black line is the value y? It's the y value of that point. All in favor? It's the height above the x-axis. No? Suppose this point was 3, 7. What would the 7 represent?
Oh, yeah.
The 7 would represent the height above the x-axis, is it not? If you come over here, it's a 7. Karen, you okay on that? Plotting points, huh? That is, so the y represents that distance right there. Now, this distance that I'm about to write in green, the green distance represents y minus y bar. All in favor of that? Y minus y bar? That's the deviation of that point y, is it not? Now, the residual, the regression line is y equals bx plus a. Now, the points in the regression line are called y prime. The reason they're called y prime is because we already are using y to represent the height of the point. But this x value has a certain crossing of the regression line, true? And it crosses it right here. So now, what is the length of this red line? Is it not y prime? True? Okay, good. Now, there's two other lines to draw. First is this black line, which I'll draw right here. Now someone tell me what the black line represents.
Y prime minus,
You're right, y prime minus,
the mean of y. Or
the green, what's the green? Y prime minus what?
y bar.
Y prime minus y bar. Is that line true? And there's only one other line left. And I'm going to draw it right here. So someone tell me what that line represents. What's the top value? Hmm? What's the top point of the blue line? What's the top point of the blue line?
Y.
Hmm?
bar.
Y.
It looks like it's right there to me, isn't it? What's the value of that point? Because I asked you. I'm getting smart.
Y minus,
So it's y minus,
y prime?
y minus, and the bottom of it is on y minus y prime. y minus y prime. So now I'm going to do that in a magnified picture, so we get that notation down. So this is my regression line, which has the equation y prime equals bx plus a. That's the equation of this line. And this is my y bar, my average y. And this is some arbitrary data point. So it has a value of y, does it not? So now this black distance is y minus y bar, the deviation of y, is it not? Now I'm going to maintain that the black distance is the sum of the red distance and the green distance. Do anybody disagree that the black distance is the sum of the red distance and the green distance? All in favor? Okay, now the red distance is y minus what? Y minus y prime, agreed? And the other distance is the green distance, which is y prime minus y bar. Y prime minus y bar, agreed? Okay. Now, this is the total deviation in y, is it not? This is the total deviation in y, meaning that it is the distance of y above the mean, isn't it? That's what deviation means. How far from the mean? So this expression on the right is the deviation or variance of y. That is, it is the distance of y from the average. Now, some of that distance of y from the average, which is the green line, is explained by the proportion. Because we identified that the reason that there was an increase in y is because there was an increase in x, and y and x are correlated. So if there's a perfect correlation, then the change in y is proportional to the change in x. So if you change x this much, then you will proportionally change y that much, for the reason that x and y are correlated by this line. So the same is true if we have scatter. Because x and y are correlated by this line, then this is explained by the regression. By the correlation. Because x and y are correlated according to this line, that's the best line of correlation, agreed? That means that when x goes up a certain amount, y is expected to go up a certain amount because it is correlated with x. But it's only supposed to go up the amount that's given by the regression line, because the regression line represents the summation of the entire correlation. So the amount of increase in y that is present, because it is correlated to x, is the distance between y prime and the regression line. And it is explained by the fact that there's a correlation between y and x. Now, if there was only a correlation between y and x, and there was no scatter amongst the points, then would not every y value terminate on the regression line? There would be no scatter, agreed? So the entire change in y would be explained by the fact that x changed and there was a correlation between x and y. But in general, those points do not lie on the regression line. In general, they lie scattered about the regression line. So this red line is the residual. It's what's left after you take out account of what is explained by the correlation. There is still an unexplained amount of change in y. And that amount of change in y is called the unexplained change in y. It's also called the residual. So the unexplained change in y is the amount of change in y that is left over after you explain all that you can by the fact that it is correlated to x. So let's take a real scatter plot and see how these points come about. Suppose that these are our points. And I pass my best fit line through it. Now, these red lines that I'm about to draw, are they not the scatter in the y points about the line of regression? It's the amount of scatter about the line of regression, agreed? Now, if it was a perfect correlation, would there be any such scatter? All the points would shrink down and be on the line, agreed? So the residual points measure the amount of unexplained change in the y values, because if they were all on the line, they would be totally explained by the fact that x went up, so y went up, naturally. But some y's go up more than that, some y's go up less than that. So they are scattered about the explanation of correlation. So these residuals are unexplained. Now, is not the amount, so these residuals, they would have some average length, would they not? Now, is not the average length a measure of the amount of correlation? If there's perfect correlation, then what's the average length of the red lines? 0, agreed? But if there's not very good correlation, then the average length of the red lines is quite a bit, is it not? So the average length of the red lines is a way that you can measure the amount of correlation that you have, the average residual length. And what it is called is the standard error of the estimate. And it's also known as sigma estimate for a population, or S estimate for a sample. Now, you already told me that the red line is y minus y prime. Remember that? So what you do is you take the sum of y minus y prime, which is all the residuals, you square it to get rid of the sign, then you take the square root to undo the fact that you squared it. And you get back to the average length of the residual. And that's the error. That's the estimate of the error. That means the error from a perfect correlation. Now, what am I going to divide by? Am I going to divide by n? Am I going to divide by n minus 1? Or am I going to divide by some other n? Well, you divide by the number of data points that are free. Now, let's say if I have n data points, you'll say, well, that means you have n degrees of freedom. But notice, what I'm talking about is the distance of a data point from a straight line. Now, how many points does it take to draw a straight line? 2. So I use up 2 points to draw the straight line, so you only have n minus 2 free points left. So you have n minus 2 degrees of freedom when you talk about regression. Because 2 of the points are used to establish the regression line. Now, it's n minus 2 if you're talking about a sample. But if indeed you're talking about the whole population, then it goes back to being the full n, because the whole population is full. So we've established one of our features of this, which is the standard error of the estimate, S sub estimate, SSE. Well, actually, SSE is not quite this. So let me rephrase that. SSE is the sum squared of the residuals, so it is simply this much of it. And it's y prime, not y bar, so I miswrote there too. Okay, so make these corrections. Now, all of these formulas are in Lane, more so than Ilkowski. Ilkowski is easy on you this time. Usually Ilkowski is the hard one, Lane is the beast. This time Lane is the beast, Ilkowski is the easy one. So watch out for Lane. Now, I want to go back to that equality that we wrote down before. We said that the whole deviation of y minus y bar, was equal to the lower half of it, which was y prime minus y bar, plus the upper half, which was y minus y prime. And that this was explained, and this amount was residual. Now, that's true for one y point. It's also true for all of them. So it's true that the sum of y minus y prime squared, I mean not squared yet, is equal to the sum of y prime minus y bar plus the sum of y minus y prime. So if it's true for one, it's certainly true for the sum of them. Now, if you do a little bit of algebra, you will establish that it's also true that the sum of this squared is equal to the sum of these squared. And you can do that algebra and convince yourself of it if you want. So we have this very basic equation, which I'll write down on a fresh board, that the sum of y minus y bar squared is equal to the sum of y prime minus y bar squared plus the sum of y minus y prime quantity squared. Now, you can calculate all of these from the table, because you're given the original y values from which you can establish y prime. As soon as you have y and y prime, you can establish the line of regression. As soon as you have the line of regression, you have y primes. So you can get all of these items, and we will in a sample table in just a moment. But the next thing to point out to you is that if I divide each side of this equation by this quantity, the sum of y minus y prime quantity squared, and this one by the sum of y minus y prime quantity squared, and this one by the sum of y minus y prime quantity squared, then on the left side, please tell me what I'm going to get.